Hey, hello and good morning. Please, can you hear me?
Yes, sir. Morning.
Good morning. Okay. Um, so today we are going to look at basically two things. Um, if we look at our course outline, you see that we virtually are looking at uh, review of differentiation, but more importantly, um, the specifics are last week we looked at the rules of differentiation and limits, but this we want to look at basically logarithm functions and then parametric functions. So that is what my emphasis will be on this morning. Um, I just want to show you what I have on the LMS. I'm still, like I said, I still have to be populating this a day at a time. Okay, so this is your course outline. So last week we looked at limit review of limits and functions. Today we want to look at 2 and 3. Hopefully by the end of next week, we should be done with all this unit 1. So we want to look at logarithm differentiation and look at parametric differentiation. Now on the LMS, I've just uploaded the material I'm going to use and then the various worksheets that you need um, to use later. Okay, so when we are done and you need more examples, you can go there to do that. Okay, so we are going to look at first the rules of logarithm functions. It's a very simple rule, and then we'll try and do 1 or 2 examples. Then I'll show you the exercises. Now, that of parametric, I have not been able to finish typing in the PowerPoint, so I'll use a PDF file to do that. Then also we'll look at the exercises and examples in there. Okay, so that's a plan for this morning. Let me know if we need to go over a few things or I need to slow down any of the slides I'm using. So let's use a PowerPoint for this morning. Okay, so what are the rules for logarithm differentiation? And then we look at examples, and then what are the rules for parametric differentiations? And then we look at examples, and then we look at the worksheets, which I'll leave for you to try your hands on. Okay, so here we're saying that if you are uh, evaluating any derivatives of functions that are complicated and involves products, quotients, and powers, the best way is to take log. Okay, so logarithm functions actually simplify problems that involves either the product and quotient, either you are multiplying functions or you are dividing functions that involves powers. So if you say y is equal to 2x raised to the power 5x, or y is equal to x raised to the power sine x, immediately you see powers. The best method is to take log on that function. So take actual normal log, or for most of us, we will prefer using the natural log. It doesn't make too much of a difference. So the method we'll see a method like that, hopefully in the next example. But these are still the rules. So first of all, if you are using natural log, then if you differentiate a natural log, you first of all differentiate the function of x. This time we are using u. So you differentiate u, that will be in the numerator, and then you repeat the original function in the denominator. That's a rule for natural log. And again, if you are using normal log, then you differentiate the u, which will be your function in the numerator, and then you repeat the function of u times the natural log of the base of a. Okay, so this is the rules when you are evaluating function using log or natural log. If the function is an exponential function, e raised to the power u, then first of all, it's like the product rule. You differentiate the power, that is u prime, and then times the original function. So e raised to the power u times the differential of u. If it's a number raised to the power u, then you differentiate the function again, u, that is u prime times the original function, a raised to the power u, then times the natural log of a. It's almost similar to that of the log of u to base a. So these are basically the rules that we need. Now, so the best way to understand this is to take an example. So remember that if it is natural log we are evaluating, first of all, when we differentiate x, I hope you can see this. When we differentiate x, we are going to get 1. Remember the rule. We differentiate the function, which will be in the numerator, divided by the original function. So here, if the function is x, okay, if the function is x, then natural log of x, when you differentiate it, differential of x will give you 1, and then the original function x. So that's why the differential of ln x becomes 1 over x. Okay, so in general, just simplifying what is in the rule, if we are differentiating natural log of a function of x, let the numerator be the differential and let the denominator be the original function. Okay, so the rule is that simple. Make sure that the denominator or the function in the denominator does not go to 0. Okay, so we'll try 1 or 2 examples. I hope by the time we are done with the second or third example, you'll be okay, and then you can look at exercises yourself. So there's the first example. If you are asked to differentiate natural log of, into bracket, 2x squared minus 1, then remember the rule. We differentiate 2x squared minus 1. That will be in the numerator, and then the denominator will be the function itself. Now, when you differentiate 2x squared, that will give you 4x, okay? And then the denominator will simply become 2x squared minus 1. So the differential of natural log of 2x squared minus 1 will give us this. This is quite straightforward. There were no powers here. Okay, let's take the next example. So find, okay, this one is in a story problem. So we have a few things we are assuming you will remember. Okay, now they are asking us to, first of all, find an equation of the tangent line. I don't know what this color is. Okay, let me change it back to blue. Find the equation, find an equation of the tangent line to the graph of this. Okay, so first of all, before we even start solving the thing, what are they asking us to find? Now, when you have an equation, first of all, when they ask you to find the tangent line to a particular equation, then that tangent line is supposed to be the slope. You know that if you have this, I'm sure when we ask, maybe let's find out how this function looks like. Function of x is equal plus ln x. Let's get a visual look on this. Okay, so plot, if we ask this to plot y is equal to ln x plus 2x. I hope I'm right. Was that the equation? I think so. 2x plus ln x. Okay, so he's right. Look, 2x plus ln x. So this is the graph. That's how the graph is. So if the question says that you should find a tangent line, this line seems to be and this line seems to be as it goes up. I don't know whether if I minimize it, I can be able to. Okay, so when you minimize it, it looks as if it is a line, but when you open it, it seems as if it's a curve. It's actually curving and going up because of the natural log. Okay, so what do they mean by finding the equation of the tangent? So the tangent will be finding the slope. when you are given a curve or you're given an equation and you are being asked to find the equation of the tangent, then you are supposed to find the equation of the slope or differentiate the function, and then the value of x at that point will be your tangent. So that is why immediately they gave us this. The next thing we did, you see me do is I'm differentiating. So I'm differentiating this function, okay? So when you differentiate 2x, we end up getting 2. And then we already know that when you differentiate natural log of x, we end up getting 1 over x. And I'm saying that the slope, when you are asked to find the slope of a function, is actually the differential of the function. Or, like I've written here, f prime of the function will be equal to that. Now, why am I finding the slope? Because at the end, I'm supposed to find the equation of the line. I'm supposed to find this equation. And please, what is the formula for an equation of a line? Is it not y equals to mx plus c? So, okay, so for me to find the equation of the line, I need to find m, which is the slope. This is the equation of a line. Either you use, let me write this here. Saying that if you are being asked to write the equation of the line, so it could be y is equal to mx plus c. This is a general formula for the equation of a line, okay? Or you could have y minus y1, which I've written here, y1 equals to m into brackets x minus x1. X minus x1, okay? So that is the equation I'm using here. So because they're asking me to find the equation of the line, I need to find the slope first. So I've differentiated the function, and you know the differential of a function is actually the slope of that function. And now I have 2. Now remember that they are telling me that I should do that at x is equal to, or at the point y is equal to 1, 2. Okay? So they want me to do this at y, 2. 1, 2. So wherever I have x in the equation, I'm going to replace it with 1. So 2 plus 1 over 1 gives me 3. So my slope is 3. Now that I have the slope, I can now write the equation of the line using the second formula that I have here. So y minus y1. What is my y1? My y1 will be the value 2. They give me the point. And then x minus x1. x1 will be the value 1. So the equation now becomes, this equation now becomes y minus 2 into equals to 3 into bracket x minus 1. Now, if you simplify this equation, you end up getting this as your answer. Okay. Kingsley, are we okay?
Yes, sir.
Okay. So basically, the first equation was simply differentiate the function with respect to x, and we use the laws of the log. The second one is an application question. We are not just differentiating. You are being asked to differentiate a function and write the equation of the line after differentiating. How do you even know that it's different? You are supposed to differentiate because they ask you to find the equation of the tangent line. When they say tangent, it means the slope. Okay, so when you have a curve and a line touches the curve, the point where the line touches the curve is called the tangent to that curve. So immediately they mention the word tangent. That brings to mind that this question, you have been asked to differentiate. So that's why I differentiated the function and I got my slope. Then I substituted the value of the point into the normal equation of a line, and I was able to find the equation of a line. So we are killing two birds with a stone. We are revising how to differentiate logarithm functions. We are also revising how to write the equation of a line that is either tangent to a particular curve. Okay, so this is a second example. Now this one, the next example will be a bit more involving. So let's repeat the rules. Now, so the rules are, first of all, you take the natural log on both sides of an equation and use the properties of logarithm to write as a sum of a simpler terms. So we are going to take another example. By this time, I'll leave the function in terms of y, and it will be a power function. Now, so step 1, take natural log. Step 2, when you are done, you differentiate both sides of the equation respect to x. You differentiate both sides respect to x, and then you solve the resulting equation at the end. Okay, so let's see how to use this rule to solve an equation like this. So this is example 3. Okay, so this one, I have square root of 3x plus 2 times into brackets 9x minus 1 raised to the power 5. Okay, so I've proposed the solution here. This one, I haven't done it. I want us to do it together. So let's see how to solve this. Let's take natural log on both sides of this equation. And then number 2, we apply the properties of natural log. Number 3, we differentiate it. And then number 4, we solve the simplified equation. So I brought the question here. Okay, now, so if this is the original question, taking natural log on both sides will give me, for the sake of time, so I have written part of the equation here. So when you take natural log of y, it becomes natural log of y like this. So the left-hand side, I'm taking natural log here. And then on the right-hand side, it means I'm taking this whole thing here. For the sake of time, I'm copying it, and I'll place it here. Okay, change it back to black so that we can tell what we are doing. So all they're asking me is that take natural log on both sides, and that is what I've done. Natural log on the left, and then natural log on the right. Okay, now, then we are going to apply the properties of log. Please, what are the properties of log here? You know that this function is raised to the power half. I hope you see it. 3x plus 2 square root is actually 3x plus 2 raised to the power half. Okay, so it means that if you are taking log on that side, it becomes 3x plus 2 in the bracket here, and then the power half comes to multiply. I hope you remember the laws of log. And then for this one, I have 9x minus 1 raised to the power 5. So based on the function that this is log, you know log, when things are multiplying, we add. So it becomes addition. And then the power comes to pre-multiply. So the square root becomes half. So first of all, the left-hand side will still be y. And then the right-hand side, the power half becomes 1 over 2. And then in the brackets here, I'm going to have 3x plus 2. Now, on the right-hand side, the power 5 comes to multiply. I've written that already. And then in the brackets here, I'm going to have 9x minus 1. Okay, so we have applied the properties of log or natural log. Now, it is time to differentiate. Now, remember that if you differentiate natural log of x, remember the rule here, the first example. When we differentiated the natural log of x, it gave us 1 over x. Okay? But in this example, we are not differentiating natural log of x. We are differentiating natural log of y. Because our differentiation is dy dx, then it will have to be 1 over y. Then you differentiate the y itself. It becomes dy dx. Because this is, you have to differentiate, first of all, find the natural log of y. That will give you 1 over y. Like a natural log of x gives us 1 over x. This will give us 1 over y. And because this function is in terms of y, we differentiate y. That gives me the dy dx. I hope you remember this rule. We learned this last semester. If you are differentiating with respect to u, you first of all differentiate the function u, then come and differentiate du dx. Okay, because the function is in terms of another parameter. It's not in terms of x. So this becomes 1 over y, then dy dx. That would be the differential of natural log of y. Now let's come to the right-hand side. Okay, so first of all, I'm going to have 1 over 2. I hope I'm right. Come in, give me a minute. Okay, so I'm going to have 1 over 2, and then I differentiate the function. Remember, this is natural log. So I still have 1 over 2. Okay, first of all, 1 over 2 will be here. Now, remember that if you are differentiating the natural log of a function, the numerator, you differentiate the function itself. So if you differentiate the numerator, what do we get? 3x plus 2, what will it give us? When you differentiate 3x plus 2, what will that give us?
3.
It will give us 3. So the numerator is simply going to be 1 times 3. That gives me 3. And then you repeat the whole function in the denominator. So the denominator, remember there's a 2 already in the denominator. So I'm just going to multiply this by 3x plus 2. Okay? So this thing, when I differentiate, I'm going to get 3 divided by 2 into bracket 3x plus 2. Okay. Now let's look at the right-hand side. The right-hand side, when I differentiate, first of all, remember that there is 5 already. I can leave the 5 here. Maybe leave the 5 here. It's multiplying. When I differentiate 9 x minus 1, what am I going to get?
9.
9, exactly. And then the denominator will repeat the function. So the function is going to give me into bracket 9x minus 1. Okay, now that we are done, we only have to make dy dx the subject. Okay, we have to make dy dx the subject, then we are done. Please, you can also see that this 5 will multiply the numerator 9 and to give me 45. I'll do all that here, but I want you to see what is happening at the bottom. So I'm just stretching this a bit bigger. Now, if I make dy dx the subject, it means this y here, the denominator y, will go and multiply. I'm supposed to have y coming up here. The y will go and multiply. It's like I'm multiplying both sides by y. But you know what y is? Y is this whole equation I place in the bracket here. The original equation, that was the question. So I am going to replace this whole bracket with the original y. Okay, and then I'm going to repeat these values that I have here inside the brackets here, and then I'm done. That's your differential. Okay, so here, the numerator is going to be 3. The denominator is supposed to be 2 into brackets. If you want to simplify, you can do that, expand, but we are only interested more in the result of the function. And then the numerator for this one is supposed to be 9,545, and the denominator will give me to bracket 9x minus 1. Okay, and there you are. Your final answer will look similar to this. Okay, so that is how we go about differentiating power functions like this. Okay, that's basically how we go about doing this. It's you first of all, the rule says that number 1, take natural log on both sides of the equation. When you are done, then you apply the properties of the natural log, and then you differentiate, and then you solve the simplified version. And that is what we've done here. Okay, so maybe we should try one more and see that we are quite conversant. Then I'll show you the worksheet on this. So this is another example. So differentiate y is equal to x raised to the power 3 over 4 all times square root of x squared plus 1. And then the denominator, we have 3x plus 2 all raised to the power 5. So the same procedure. Let's take natural log on both sides of the equation. We apply the properties of the natural log, then we differentiate, then we solve. So let's try and do this as well. I'm sure this work will be more involving, but if we differentiate the left-hand side, please, I hope you can see the equation here. If we take natural log on both sides, the left-hand side will be equal to y. And then if you take natural log on whatever I have here, basically it means this whole thing is what is going to come up in here. I hope it will allow me to do that. Okay, and then just change the color back to black. Okay, so that is taking natural log on both sides. Now, we don't have to take our time and apply the properties of log. Okay, so as we type, I have to be pushing this up, because I want this to be. So let's take the properties of log. Okay, now, if you look up here, x is raised to the power 3 over 4. Okay, and it is multiplying whatever I have here. And then the denominator here, I have 5, 3x plus 2 raised to the power 5. Okay, so let's look at, because this is multiplying this, it becomes addition. That's why this is addition. And then because the numerator is being divided by the denominator, then it becomes subtraction. So let's take care of this first. Okay, so this should give me, I'm sure that you should realize that the power 3 over 4 will come and multiply. So I'm going to have, or maybe just let me leave it there for the meantime. So I have x raised to the power 3 over 4. And then the numerator, I think I should bring it here, 3 over 4. Um, 3 over 4 natural log of x. And then here, I'm going to have 1 over 2 because the square root, 1 divided by 2. And then we have in the bracket here, x squared plus 1. Okay. Now the denominator, we know the power 5 is here. So it means 5 multiplies the terms, and then in the bracket, I'm going to have 3x plus 2. I hope we are okay. I hope we are right. Everybody's on the same page here. Okay. Now, so what do we do next? Now, then we now differentiate. Remember the rule for differentials. If you differentiate natural log of y, it's going to give us 1 over y, then dy dx, because this is a parameter in y. Now, then we come here. When we differentiate natural log of x, that will give us 1 over x. But already, there's a fraction outside. So 3 over 4 is the fraction outside, all times. And then the differential of x, natural log of x gives you 1 over x. Now, when we come to the term on the right and the next term, we still have 1 over 2 outside. Now, when we differentiate x squared plus 1, what would that give us? Let me be sure. What is x squared plus 1 differential?
2x.
That gives us 2x. Okay. And then the denominator will repeat the original function. So we are going to get x squared plus 1. Okay, then we come to the right-hand side, okay? We have 5 multiplying, the numerator is going to be 3. When you differentiate 3x plus 2, that will give us 3. And the denominator is going to give us the 3x plus 2. Okay, so that is the differential of this function we have here. Then you know what we are supposed to do. Solve by making the y dx the subject. And immediately if I do that, this y here is going to multiply this whole expression that I have here. Okay, so you can either simplify them or you can leave them like that. So this y that comes here is going to be original equation that I have here. So that is going to be in the brackets here. Okay, wait a minute. I think I need to use the correct brackets. Think about this. Okay, so using this now, when I put it in, it should accept it. Okay, now it's accepted. The brackets now expands. So that is for y. And then all that we have here, we are simplifying the whole of this, okay? So the first one is going to give me 3 divided by 4x. Then plus the term on the right. Oh. Then this term is going to give us 2x in the numerator. Or if you take your time, you see that the 2 will cancel the 2 in the denominator. So you'll be left with x divided by x squared plus 1. So x squared plus 1. Then we are left with minus, the term out there should be 5, 3, 15 divided by, the denominator is going to give us the 3x plus 2. Okay, so that will be a simplified solution for the differential of our equation has disappeared to the top because of space, but I hope you saw it. Okay, so when we differentiated this function, this is exactly what we get at the end. Okay, so at this stage, do I have a question? Is there any question or any comments? Okay, so our questions here, or the questions here are quite straightforward. So I have screenshot a question from online for you to try. So take your time and try these questions later. Natural log of x squared plus 1, natural log of 1 plus ex, natural log of 1 plus square root of ex minus 1, and then log to base 2.7 x cubed plus e sine of it. Are solutions to all this, but kindly give it a try and see. Okay, and then what will follow should be worksheet, but I'll look at the worksheets later. Okay, so like I said, for parametric function, having been able to type the terms in the PowerPoint, so I'm going to use a PDF document to go through that. Then we will look at some examples, and then we end with the worksheets. So let's look at parametric functions. Okay, so first of all, what is all this about? There's a few things we need to go through. So instead of a function in y in terms of x being defined explicitly in terms of an independent variable x, it is sometimes useful to define both x and y in terms of a third variable. So the concept of parametric function is all this while we've been defining y is equal to something in terms of x. So y is dependent on x. But sometimes both y and x are functions of another function like t. Okay? So the best way to go about it is to express the problem in terms of a third variable, say t, so known as a parameter. So what we are trying to do is that how do we end up differentiating such problems in that form of parameters? So I have a function y, but it's in terms of t, our function x is also in terms of t. How do we go about it? That is basically what parametric differentiation is all about. So in order to master the techniques explained here, it's vital that you undertake a lot of practice so that you become you're very matured and balanced in this. So all we are looking at is, first of all, what is the parametric definition? How do you differentiate the function? And then if you are second derivatives, how do you handle it? Okay, so first of all, we are recapping what a parameter is. Sometimes relationships between two quantities or variables are so complicated that sometimes you introduce a third quantity or variable in order to make things easier. So in math, this third quantity is the parameter. So instead of one equation relating, say, x and y, we have two equations, one relating to x with the parameter and one relating to y with the parameter. So in this unit, we are just going to take an example like that. So let's pick an example. So an example is that consider the equation x is equal to cos t, and then y is equal to sine t. Okay, both t lying between 0 and 2 pi, because you know sine and cos functions, they actually oscillate within pi and 2 pi and on and on and on. So now, how do we go about it? So first of all, if you take your time and plot these functions, you will be able to tell some of the values. So if they're taking when t is equal to 0, x will be equal to cos 0, which is 1. And when t is equal to 0 for sine, y will be equal to 0. And then when t is equal to pi on 2, x will be equal to pi on 2 for cos. And then when t is equal to pi on 2, sine will be equal to 1. So you see that the values of both x and y are oscillating between the values of 0 and 1. And the function is shown below. We know these things. Last semester, we saw some of these things. Okay, so these are the table of this graph up here. What are the values of t, 0 to pi on 2, that is 90 degrees, to 180 degrees, to, I think, 270, and 2 pi. 2 pi is what? Okay, so it's oscillating, x is oscillating between 1 to 0 to -1, and it comes back to 1. And y is oscillating between 0, 1 to 0, -1 to 0. So values of x and y are given in the question below. Why are we doing this? Because the original equation has been given in terms of a third parameter. So we want to know when the values of x and y are changing. Remember here that the values of t are in pi. So you want to know the values of both x and y. How would the function look like? That's why they took their time, or we take our time to look at the rate of x and changing with respect to y. Okay. Now let's come now and look at the graph. So plotting the points given in x and y coordinates in the table up, joining them with smooth curve, we are able to obtain that the sine curve and then the cos curve, it gives us a circle. I mean, virtually by looking at what we have here, the way they're oscillating, they virtually complete a cycle for us. So that is what we have here. So the parametric equations defines a circle centered at the origin and having a radius of 1. So x cos t and y sin t for t lying between 0 and 2 pi are parametric equations which describe a circle with center 0, 0 as the origin and the radius as 1. Okay, so we have been able to explain what happens with trig functions when they are written in form of parameter in a third variable. Now, let's now look at the differentiation aspect. So if you want to differentiate these two functions, remember that it is often necessary to find the rate of change of a function define parametrically. That is, we want to evaluate dy dx. That's the question. Okay, so to find dy dx, remember that x is in terms of cos t and y is in terms of sine t. So if I want to differentiate x, I have to differentiate x with respect to t. Do you get it? So this will be dx dt. And if I want to differentiate y, I'll define y with respect to t, dy dt. So dx dt, if you differentiate cos, it gives you negative sine. And if you differentiate sine, it gives you cos. So dx dt will give you negative sine t, and then dy dt is going to give me cos t. Therefore, if I write dy dt, okay, it will be equal to dy dx times dx dt. We want to find dy dx, so we must use both dx dt and dy dt. So I'm saying that if I take dy dt, it can be written as dy dx, which is what we want to find all times dx dt. You know this when you cancel it to end up giving you dy dt. So now if you make dy dx the subject, you see that you are going to get dy dt divided by dx dt, provided the denominator is not equal to 0. Okay, I hope you guys are following. It's basically taking the parameters that have been given, the third parameter, and then rewriting the differentials in such a way that you end up getting dy dx in the differential. So, like I'm saying, we want to find dy dx, but to find dy dx, actually you must divide dy dt over dx dt. And that gives us the equation we have here. Now we have already differentiated dy dt. It gave us cos t, and then we also differentiated negative sine t. That is, the dt gave us negative sine t. And please, I hope you remember the trig differentials. When you differentiate cos t over negative sine t, it will give you negative cot t. Actually, you know tan of an angle is sine over cos. So it means that if you revert it, you'll find the inverse of it. That gives you cotangent. So cos over sine will give you cos of that function. We are just rewriting this equation as this. Okay, so that is actually the whole idea behind parametric differentiation. Okay, so all we do is that we differentiate the function. So if x is in terms of t and y is in terms of t, dy dx will be dy dt divided by dx dt, and make sure that the denominator is not equal to 0. Okay, so another example here, second example. If x is equal to t raised to the power 3 minus 1, and y is equal to 4 minus t squared, then what is dx dt? Dx dt is going to be 3t squared minus 1. I hope you can know that. And then dy dt is going to give us negative 2t. When you differentiate 4, it goes to 0. But if you differentiate negative t squared, it gives you negative 2t. So dy dx will be this negative 2t here, all divided by 3t squared minus 1. Okay, and then you realize you are done. Okay, so basically that is what parametric differentiation is all about. You only have to find the various parameters that are being defined, and from those parameters, then you can be able to evaluate the function that has been given. Okay, so there are a few more examples. I've shared all these documents. Like I said, they are here. I think they are here. These are the notes of the parametric differentiation that I'm using right now. This is a PowerPoint that I used, and then these are the worksheets. Okay, so now I have to introduce you to the worksheets, and then I think I should be done with you. I'm really going quite bit by bit this semester because I realize the more I give you, when we meet face to face, it means we have to do quite a lot more. But if you're able to, what's the word? Pace ourselves in such a way that we can all be abreast with the stage. Secondly, too, because this is a new It's a new course. The materials, I'm developing them as we go. So I need to be able to make sure everything that I share, I'm able to give you some questions on them. So let me introduce you to the worksheets. And if you don't have any more questions, then I think we will end there. Okay, so let's pick the worksheets. The worksheets are not, the questions are not too many. Let's see. And for some of the worksheets that I have, the solutions are also there, but I will recommend try and do them yourself. These are, hey, it's not small. So this is 16 questions, okay, for the log function. So use logarithm differentiation to differentiate this function. So these are power functions from the beginning. So like I said, you take natural log on both sides, and then you will be able to use the powers of the log, the properties of the log to simplify it, and then you make dy dx a subject. So question 1, the same. Question 2, the same. Question 3 and 4, the same. Question 5 and 6 are similar to what we did today. Okay, these are product rule. So if you take log on both sides, then definitely this will be natural log of y, and then this will be natural log of this whole thing. But here, because they are multiplying, you are going to add this natural log and then use the power rule to handle it. The same applies to this. So question 5 and question 6 will be quite similar to what we did. Then question 7 is giving you quotient function. So again, if you take natural log on both sides, then you know that the numerator, the denominator will be subtracted from the numerator. 3x to the power 4 minus 2 raised to the power 5 minus natural log of 2 natural log of 3x cubed plus 4. And then again, you differentiate and let the y come to the right. Now this number 8 is similar to number 5 and 6. Okay. See what number 7 is quotient rule, number 10 is product rule, 11 is product and quotient, and then 12 you have 3. So they are all product rules. 13 is product, and 14 is quotient, 15 is product, and 16 is product and quotient. So the examples are enough to equip you again for you to be able to be very conversant with these rules. Okay, and I said, for this example that I've given, I just make sure that the solutions are at the bottom. They didn't go through all the steps. Just after one step, you see after one step, they have the solution. So it will be good you go through the 4 points I gave. Take natural log on both sides. After taking natural log on both sides, then you come and use the properties of the log, then simplify it before you make the yd as a subject. So even though it has been solved, they have jumped quite a lot of examples. So it will be good you work through them one by one and verify your answers as you go on. Okay, so that will be for the functions on logarithms or differentiating with respect to normal log or natural log. Then the second one are the parametric functions. Okay, so this one is similar to what we did. X is in terms of t, y is in terms of t. So remember what you need to do. It says, first of all, write down the coordinates of the point of the curve where t is equal to. So it will be good you take what is the value of x when t is equal to 0, when t is equal to 1, form a table by 8. And then when you're able to find that, then find the value at t at the point of this. So the initial questions, you are just finding the point of these parametric functions. But I think when you go down, they will ask you to differentiate the functions. Okay, so these materials will help you to practice these two things that we've learned, both logarithm and parametric functions. Okay. Any question? This one is a bit involving. There are a lot of teaching materials at the bottom, but please make sure that if you are practicing at least the first 10 questions, you should be able to look at them. The first one is 8. The second example is how many? It's also 7. Okay, so I'll recommend that for each session, maybe take 2 or 3 from each session and try and find either you are plotting their points. This one, you are asked to differentiate. Okay, so the first part is the first part of the lecture material where you find a point of X, a point of Y with respect to the T. And then here you find with respect to the functions of trig functions, you have to find respect to pi and pi over 2, and then pi over 2 pi, and on and on and on. So each of them will help you to practice what we've done today. Okay, so Kingsley, I'm done. Any questions, any comments? I haven't been able to create multiple choice quizzes yet. If I'm able to do that, then I will add them on the LMS. I need to create a question bank. So maybe give me the end of this week and see. Maybe I'll be able to do that of session unit 1, and then you can take your MCQs on that. That will also prepare you for your mid-semester as well. Okay, so today we were 13. Who did I miss? Oh, engineer is here. I can see Engineer Philip. I need to thank you guys. So thank you very much for all your help. You guys made my day. Last week and the week before.
No thanks. And thank you for always try to equip us so that we'll be able to stand in the society as a whole.
Yes. So I appreciate that too. Okay, so let's build the bridges gradually. Let's find our feet for each session, and by the time you realize you will be done with year 1. I hope you will make us proud out there, definitely.
Yeah, but say if somebody tells me or somebody prophesied to me that I will be able to solve calculus and then I'll be able to understand calculus a bit, I will
You
agree
wouldn't
with the
have believed
person.
it, sir.
Yeah, because
Yes.
the way they say calculus is everybody say I mean like they will say scary things that will scare you away. So I'm already scared when I saw calculus on our
On
timetable.
your timetable.
Yeah, first semester.
Yeah.
It's all about practice.
Exactly. And it also depends on how you are exposed to it. Sometimes you may come across tutors that may virtually teach you the theory, and they expect you to do all the hard work, the hard lifting. But when the examples are gradually taught and you are able to follow the steps, you realize you can easily do them yourself and be able to understand. So we'll see how best we can help all of you.
Okay, sir. Yeah, we really appreciate it.
Okay.
Okay,
So
sir.
thanks for coming.
Sir, thank
Yes,
you
please.
very much.
You're welcome.
Uh, Sir, please, I want to find out whether the slides that you used this morning, you'll be sharing it to us, or it's
Oh yeah. I've already shared. I've already
It's on the
shared it.
LMS.
It's on
It's on
LMS
the
right now.
LMS.
Okay.
That's the one I use right now.
Okay.
Unfortunately, last week the one I used, it's not on GCTU PowerPoint mode. That's why I haven't shared it. If I'm able to do that, it will be here. So last week I didn't share that one. I think you need to remind me. I'll work on that and also share that. Okay, so enjoy the rest of your weekend. Hopefully next week we are going to continue with the outline, and gradually we'll be able to see our way through with this course. God bless you, and take care.
Bless it, sir. Yeah.
Bye.
Hello.
Yes.
Hello.
Hey, we are online, we are online.
Okay, so our next lecture is I think at
You can, okay, you can call the lecture to join them. We do everything fast, but then go now.
what's the call to find out?
We are starting
Okay.
9:15. 9:15.
9:15 years.
Well, if you can
It's
tell them then go start the thing
let me
earlier.
call to find out because some of them they've scheduled their time and everything.
Yeah.
So let me call to find out. Hello guys.
Yeah, Sina.
Hello, Kingsley.
I just called him and he said at 9 o'clock. We should wait for the 9 o'clock.
Okay. I just say the man will come around and we do everything fast. So by 3 o'clock we
Me,
finish
that's
all.
why, because if he come, after the circuit theory, then we get electronics, which is Dr.
Yeah.
Samuel Akwakwa. Before Insan will come again for electrical engineering drawing. So, he get two with us, but Dr. Akwakwa did the middle. Of
You
in two,
go fit even take this hour to do
to do like to take one. Then you
Yeah.
continue with the next one. So like the other one, at least we've combined everything together.
Yeah.
And he even asked me of the timetable. I explained everything to him, but he still says that 9 o'clock. So which means you teach the first one and break for Dr. Farquhar, then you come again.
Okay. So we there
So
around.
let's wait for him for the 9 o'clock.
Okay.
All right.